take that. We'll take that. We'll distribute it equally. Get to everybody. Side. Good. Good weekend?
Yeah.
Good. No. Good. No. That was like 5 goods and a no. We'll take that as 83%. So.
Make that 2 no's.
We'll take that as
3.
50.
I'm a maybe.
What's 5 sevenths?
I don't know, but
70%. How did I do that so quickly? 5 sevenths. No, don't give me that crap. How did I do that so quickly? It has nothing to do with math. It has to do with math you guys learned when you were probably in 4th grade. 5 sevenths. It's a fraction that keeps coming up more and more in my life. I wonder if it comes up in your guys' lives. I don't know if you ever need to know the value of that as a percentage. Keep the value of 1/7 handy. What's 1/2 as a percentage? 0.5 is a decimal, 50% as a percentage. 1/3. 33%, 0.33. 1/4. 25%, 0.25. 1/5. 20%, 0.2. 1/6. This is where it starts going downhill. Maybe. 1/6. Why does this start going downhill at this point? Maybe. Well, 6 doesn't divide into 100 evenly. I think that's the problem. 1/3 shows up so much. 3 doesn't divide into 100 either, for that matter, right? But think about this. 1/3, you knew 1/3 like that, right? It's 33%. So what's 1/6 going to have to be? Half of that. Think about it. 1/6 has to be half of 1/3. It's half as big, yes? Which means the percentage is half as big as whatever the percentage 1/3 was. If 1/3 was 33%, that means that 1/6 has to be half of that, or roughly a little under 17%? 16 and some change? I think 16 and 2/3 is the exact, because 33 is not really 33, it's 33 and a third. There you go. So roughly a little bit lower than 17%, which brings us to 1/7. Now that's a little bit uglier. A 7th is a little bit uglier. But it's one of those numbers that for some reason keeps showing up in my life. After you go to 1/7, the numbers return to some level of normalcy, like 1/8. And 1/8, we see that constantly when you buy a pizza. You know, you buy a pizza, it's in eighths. And you can figure out pretty quickly that's about 12.5%. That's 12.5%. 1/7, this is just, I've noticed this is a handy number to keep around, is 14%. So 14 times 5 is actually pretty simple. That's what 5 sevenths would be. It's just 5 times 14 becomes 70, so it's 70-ish%. It's just one of those little math tricks. I shouldn't even say it's a repository. Now you got to remember, I can remember almost nothing. Right? My memory is terrible. You guys know that. It was a quiz question from a couple weeks ago. But for some reason, 1/7, and this is the 3rd time this week, this weekend, it came up. And it's interesting, it came up right now. And it would change again, of course, if we start voting and how the weekend went again. But it's just one of those things, it's interesting. I've noticed that those prerequisite skills of decimals and fractions and percentages, they hang people up, and I don't know why that is. So we'll bring them back. We'll keep bringing them back in this class, because although factoring quadratic equations I don't care about, and you don't care about anymore either, I do care about being able to like estimate percentages and things like that. So when you encounter them in your lives, you can deal with them in a proper way. Okay, nothing's due today as far as stuff to turn in. Here's some old quizzes. I'm going to leave these up here. You guys can grab them. It's the website quizzes from the first week. I will have stuff on Wednesday. Whatever you guys turned in last week got picked up today by Emily. She does quizzes. She likes doing projects too. She apologizes for not picking them until this morning. I just saw her about an hour ago and she went and picked them up. So she's grading them right now, and we'll get them back to you on Wednesday. So you have all those. As soon as I get them back from her, though, I'll put them into the grade book and send you guys a progress report. So you'll have updates as soon as I get stuff back from her. Within 10 minutes, you'll be updated as well, and then you'll get the hard copies back on Wednesday for you. Projects due Wednesday. Don't forget that. There's a couple other quizzes I think I put due for Wednesday too. 2 other ones. I'm not going to get to the 3rd one, unfortunately. I'm having a hell of a time getting good GPS data for Iowa Street. I've got the pictures, I've got the video I wanted to shoot, so that's getting there. And I've got the quiz kind of lined up, but I need the data for you guys to actually crunch. And the iPhone doesn't have a very good elevation tracker that I can find. I've got a couple more I'm going to try today. So I'm probably going to put that quiz on for the following week, for week 4, just because rather than, if I put it up now, it's due in 2 days. That doesn't seem like enough time for you guys to get in there if you want to do it. Plus, if there's already 2 quizzes, you're diluting down your time even more. So I'll get the Iowa Street stuff updated for next week. And it doesn't matter if it's next week or this week. I mean, it's a quiz that's available that you can do if you want to or not. And that's that, I think. Yeah, that's what we got to talk about that. Any questions you guys have for me? Dead silence. Not even breath. Not even breathing. Breathe, please, please. It's Brittany, right?
Yeah.
Yes.
On the graph problem, are some of the answers going to be points or just?
That's why it says approximate as necessary.
So you
Somewhere up there. Yeah, you got to kind of ballpark. And this again it's what I like to call an American math skill. Not an algebra math skill, but an American math skill, where you see a point on a line and it's not doesn't fall exactly on an integer value. Just get a ballpark of where it has to be. Like if it falls between 1 and 2, but it's like here, call it like 1.3 or something like that. And Emily knows when she looks at that to give you wiggle room around your solution, which is something I need to untrain students of mathematics. It's because you're so used. I know Hawks is a chief offender, and that's why I can't use Hawks in this class, because if I'm asking for approximations, I can't use Hawks because of that, because I have to program in infinitely many values, and I don't want to do that. So. Cool. Good. So yeah, approximate as you need to, for sure, for sure. Some of them do, I think, the way I set those up, I think some of them do pass through integer points, but then others don't. And I'm trying to get you guys, again, thinking in terms of reality, which is how you approximate values. I'll give you a perfect example. I'll give you an absolutely perfect example right now. And then we'll get you guys outside, because I am easily sidetracked. But I want to show you a perfect example. All right. I built this yesterday. Let me find it. Here it is right here. Okay, that right there. It's a compost door for our chicken coop. So we have this big chicken coop in the chicken run, and I'm breaking my back because the thing's 5 feet high. I built it all with scrap wood that I got off the building site, the big scrap pile. It's like, you guys throwing these like 12-foot long 2x4s away? They're like, yeah. And I'm like, can I just take them and build something out of it? They're like, yeah, hippie. So I got this like 5-foot tall chicken run, which is fantastic. It's like 25 feet long, 5 feet tall, and 6 feet wide. But we like throwing compost in for our chickens. They root through things like carrots and old strawberries and rotten fruit. So our backs are breaking though, because we have to walk in there and like dump it in. So my wife's like, why don't we go to the door? I'm like, it's a brilliant idea, babe, brilliant idea. So I took the old coop that was here, it looked kind of like this side over here, and just ran a couple 2x4s across, leveled them out, and then built the rectangle door with the supports and put it in there. Well, the amount of geometry that I had to use to do that was awesome, which is what I was stoked about. But the other thing is the approximation. So here's a question. If the distance from this side of the opening that the door had to sit in to the far side was 42 inches, how wide would I have to make the door to fit in that opening?
41.
Gotta go for 41? Anybody say 42 because the opening's 42 inches?
Wait, how big are those thingies? The 2x4?
The opening is 42 inches wide. That's all I have to know right now for this question. 42 inches wide. How wide would you have to make the door to fit it well? 41? I gotta vote for 41. Vote 42? 42? 40?
I'm going 41.
Yeah.
41?
I'm going with
40? Okay. Now when I say well, I could make it 24 inches wide and then have like a 24-inch gap on one side. I could do that. But I want it to like close like a door. You know, like close it so it shuts and latches and then open it back up again. 41 3/4 inches, 41 1/4 inches. And here's why. What do you have to allow for? 3 things you have to allow for. The hinge. The hinge actually is, well, if you build the door right, the hinge is just a matter of putting the thing in the right place and screwing it in. The latches take up space. So when you put these latches, you can't see them because the door's open. There's a latch there and a latch there. That occupies about 3/16 to 1/4 of an inch depending on where you put it in. So you have to make space for that or hollow your door out to make clearance for it after the fact, which I don't have the tools for, so I don't want to do. The latch, what's the other thing you have to allow for?
Swing room.
Swing room! Brilliant. Yes! When you open a door like this, the back corner swings out due to geometry. It's part of the circle at that point. When you open this door, you have to imagine it's a circle with a radius that starts at the hinge and ends up at the outermost point of the door. Well, the outermost point of that door, when it swings through the opening, is the back corner of the 2x4, which is 3.5 inches wide. You have to make room for that back corner to swing out. How many of you thought about that? Hardly anybody thinks about that, right? I thought about it once about 15 years ago when I built my ferret cage, and I didn't allow for that. And I know how to measure. Yes. But it's not just about measurement. It's not just about exactness. It's about these little tiny adjustments you have to make. Like that quiz you're taking for Wednesday. Little tiny approximations. And then you have to deal with the fact that the damn ruler's in 1/16 of an inch. And if you do the mathematics on percentages and things like that, they end up in tenths. I got a ruler with 1/16 of an inch without tenths marks. So when my calculation, I run Pythagoras to figure out the diagonal, I'll have you do that too. I could do a week's worth of 105 on just this door, believe it or not. Believe it or not. Why are these in there? Why are these in there? Brace support pulls it into 90 degrees. Tons of geometry in this bad boy. Tons. Why does it brace? Why does putting a diagonal into something brace it up? But why does it work? How does it hold it so it doesn't... Because if you take these out, I built them with those out, the whole thing can go like this. You put those in, it can't do that anymore. Why? Just say geometry. Geometry is why. Because if you don't have these points here, you allow these 4 points to vary. But as soon as you lock this in, you've created these 3 what are called non-collinear points. They are not allowed to vary anymore because you've got a fixed side, and a fixed side. Until you put that in there, you only have 2 fixed sides in any given triangle. For example, imagine you had this fixed side, this fixed side. Well, then you've got this side going across here, which notice I didn't put a big one across the middle because the damn thing weighed too much. I was afraid the hinges ripping out of the wood. So if you don't have the diagonal in, when you start shoving these 2 are fixed, but they're going to go like this. As soon as you lock a 3rd side from here to here, it can't do that anymore. The 3rd side links it up. It's called the side-side-side postulate in Euclidean geometry. It's amazing how much mathematics happens when you do something like building a door. Who's built a door? Who's built a couple of you? Yes, a couple of you. It can be challenging the first few times you do it when you're trying to allow for all those swing room. Was that what it was, Michelle? Swing clearance? Swing room. That was wonderful. Is that an industry term? I love it.
The room that there is for it to swing.
Exactly. I love that. It's so sensible. Swing room. So that's why I like the little quizzes like that. They're like a gap bridger. It gets you into the idea of making these proper sized assumptions. When you encounter something like this, you actually have to deal with it. I even put a header on here. Okay, so I get that all math isn't useful all the time. I get that. I get that. When you look at that quiz for next week, you're gonna look at it and go like, holy crap. This is ridiculous. Well, kinda. Maybe the equations themselves are ridiculous, but the method of solution is not. It's actually extraordinarily functional. So, anyway, I wanted to share that with you. And it ties back into Brittany's question about the quiz as well. So today, what I have for us to do today first is to